Okay, the mean of the sample mean. Is written as like that. Okay, is equal to population mean. That is this. So every time when you talk about central limit theorem, the first part, what you need to write down is this one. You have to know the meaning of the mean. Are you clear? Okay. The mean of the sample means. That means in this part, our variable of interest is the mean of the samples. Each samples got its own mean. So we are plotting the mean of the exotic samples, not the individual value. Understand? Okay. Second part is the standard deviation of the sample mean. So that means this is talking about your variable. Okay, is equal to the standard deviation of the population divided by the square root of sample size. I write in word for you to see. So this is written as like that. So this is the first part of the central limit theorem. Are you clear? So in exercise 9B, question 1, you should be able to do. Don't read as X bar 4. Always read as standard mean, sample mean of size 4. Then that give you a better idea. X bar means your variable is the mean of each sample. The variable. So this particular variable, that is X bar 4, will have the mean equal to the population mean. And this X bar 4 distribution will have a standard deviation which is equal to the population standard deviation divided by the square root of the sample size. This is the formula or the theorem that found by a statistician. They have run through a lot of examples and experiments. If you want to come up with your own formula, then you go ahead and do a research for 10 years, 20 years, I don't know. Do you get me? So this is the key of 9B. Okay, can you please? And one, okay, you see how I do 9B question 1. Okay, 9B. Question 1A. So I will write down the mean of X bar 4 is equal to the mean of the population, then I will write down is equal to 20. I always have that kind of habit. And the standard deviation of X bar 4 will be equal to the standard deviation of the population divided by square root of n, which is equal to 6 divided by square root of 4, which is equal to 3. Done. Okay, now, are you clear? Okay, now I want to, can I just do this further? Do something about it? Okay, now, let's look at, is this possible for me to ask you to sketch the graph? Okay, if I give you this information, if X is normally distributed, okay, what can you say about X bar 4? If X is normally distributed, X bar 4 is also sample means variable of sample size 4 will be, is also what? According to central limit theorem about the shape, is also what? Hello? Are you write down? I don't write. It's also what? It's also normally distributed, correct? Regardless of the sample size. Am I right? Okay, so now can you please sketch the graph? This the graph of X bar and X bar 4 on the same axis. So my this variable can be X or X bar 4. So how to do? Can you please try to sketch? One is broader and shorter. One is narrower and taller. Those in the class I can check. Those online will check by themselves. Yeah, sketch. if I write this one down, my X is normally distributed. The mean is 20, the standard deviation is 6. My X bar 4 is also normally distributed. And the X is 20, the mean is 20 and the standard deviation is 3. Correct? So you have to prepare, all have the same mean. So I write 20 there. Then I make 3 marks. Why I make 3 marks? Because for any given variable which is normally distributed, the probability of the value within 3 standard deviation away from the mean, this is true fact that every one of us must know. The answer is almost equal to 1. Am I right? So this is a true fact about in chapter 8 that we have learned. So we are going to use this intensively in this chapter. Okay, you compare, double. So now I'm going to draw my X first. So my X start from here, fade away here. Inflection point around here. When you sketch the graph, you cannot just do the graph without all these important points. How can you just simply draw? So this is my X. So I'm going to draw my X bar 4. Start from here. 3 standard deviation away here. Here is 20, here is 26. Am I right? Here is 32. Here is 38. You must put down the scale. 20 minus 6, 14. 14 minus 6, 8, huh? 8 minus 6, 2. So the curve go like that. Do you know it's very sad now? I taught you how to sketch the graph so many times, you just ignore it. When it comes to graph sketching, there is no faster way. You have to follow step by step, means step by step. It's the meaning of X bar something. So next time you want to explain this, you will say that X bar 7 is the sample mean of sample size 7, which means randomly pick 7 values of X and calculate the mean. Got it? You do it like that. Okay, now find the mean and the standard deviation of X bar 7 shouldn't be a problem, correct? We go back to the formula. What is the formula? Mean of X bar 7 is equal to the population mean, equal to 5. Don't always just straight away write equal to 5. Okay. And the standard deviation of X bar 7 equal to the standard deviation of the population divided by the square root of the sample size, which is 2.16 divided by square root of 7. So approximate value. Clear? Can or not? Okay, now let's go to question 3. Please go to question 3. I will go through every single question with you. For this question, after I read the question correct, I will have all this information. Okay, I will write down X is the thickness of a sheet of paper produced by this company using this machine. So X is a population. Okay, the population X have this mean and this standard deviation. So now we are going to talk about the variable X bar 10, which means the sample means of the thickness of 10 randomly selected sheets. So there are many. Okay, so a quality controller go and get one sample. So this is a sample. A sample of 10 sheets. So, got it? So this particular, so the quality, what is the corresponding observation value of the random variable? That means I want to know the mean of this sample. I only have one sample here. Okay, so can you please take out your calculator and add up, divide by 2. Hello? Are you clear? Okay, so what is the answer, Thaddeus? 2.975. So this is the mean of a sample that I picked. Okay, now. Look at what is the corresponding observation value of this random sample. So this is the answer, correct? And if you key into the calculator, the standard deviation of this sample. Okay, may I know what is the answer? We write S, standard deviation of a sample, you write S. So can I know what is the answer? Did you key all that into your calculator? Please do so. Corresponding observation value. You can say the mean of this sample, the standard deviation of this sample. May I know what is the answer? So for part A, you are not supposed to use the central limit theorem because we are not talking about the mean of the sample mean. We are talking about the mean and the standard deviation of this sample. So what is the answer? Hello? Did you key into your calculator and use one var stack? Hello, Xinqi or Xinren, can I have the answer? So that's why I told you this is a symbol for sample mean. So when you look at your calculator, you have to look for this S. Cannot sigma. Hey, are you in my class? When you do part A, you didn't do this part, is it? Okay, can I have the answer? 0.13 mm. Understand? Is this particular sample the deviation? So you have to have very clear cut. Get me? Okay, now only part B. Only part B, you start to, what is the mean and the standard deviation of the sample mean? So this particular part, then only you write like that. Which is 3. And the standard deviation of this one is equal to population standard deviation divided by square root of 10. Then you get 0.12 divided by square root of 10. Then you get the approximate answer. Are you clear? If from part A you key into the calculator, that is the mean of a sample and the standard deviation for this sample. So sample standard deviation, you use S to represent it. The variable for part B is the sample mean. The variable for part A is the individual value of 10x. Understand? You see the difference? So you have to have very clear cut of what is going on here. Okay? So let's go to part 4. Question 4. You have to let the variable. Okay, we let the variable x. So you write down x is the what? Length of screw produced by a machine. Okay. So that means this represents your population. Yeah. So I will say population X has the mean of 75 and the standard deviation of 0.5 mm. Okay, now let the random variable x bar 50. So now, can someone define what is x bar 50? X bar 50 is the sample mean of sample size 50. So that means, what does that mean? If you put in bracket, randomly selected what? 50 screw. The mean of randomly selected 50 screws. Correct? So that is the meaning of x bar 50. So I should put the means because there are many. The means of randomly selected 50 screw. Okay, so the rest, you should know what to do with it. So every time, please learn to define, like what I encourage you for chapter 7 and 8. Am I right? So same go with here. So can you? Okay, so please take some time to finish the rest. So Monday I will go through exercise 9C. Can you please go to page 264? Yesterday, we just read something, correct? We forgot about the notes there, correct? Yeah. So the first note, I have explained to you why, correct? Then the second note, second point there, they say, if the end observation are chosen without replacement, please underline the word without replacement. From a finite population, then n must also be small compared to the size of the population. This is to ensure that the observation are approximately independent. So you see, without replacement, then they put the word approximately independent. So when you say independent, means in statistic or in probability sense, that means you have an equal chance to be selected. Then why you say have to be small? The reason is because if it's big, then the rest, each one, the probability of being selected as part of the population will become bigger and bigger. Just to give you an example, if for example, I have 100 in the population. So now I select one. Okay, so the probability of selecting that one will be equal to 1 out of 100. Am I right? So now I don't put it back. So now I only have 99 there. So I select another one. So the probability of this selection will become 1 out of 99. So are they the same? Equal chance of being selected? No. That's why they say you have to put it as small as possible. So 1 over 100 and 1 over 99 is almost the same, correct? That's why they put it approximate. But if I go to, if I select 10, then that will be different. So the 10th that I select, the probability will be what? 1 out of 90. So you see, the chances will become more and more. So this is no equal chance, because when we talk about random samples, means everyone in the population has an equal chance to be selected as part of a sample. That is called random sample. That means you should select with replacement. You get me? So please go back and find a definition for random samples. What do you mean by random samples? A random samples means everyone in the population has an equal chance to be selected as part of the sample. Everyone in the population has an equal chance to be selected as part of the sample. So you must do it with replacement. You don't select according to certain order. First 5, last 5. No. Understand? So that means when we talk about random selection, there is no specific order. of selection. Do you get me? Hello? Because you have to define this in your folio. So better go and read that random sample and define it properly. But in my random sample, a random sample means a sample which is selected from a population, and everyone in the population has an equal chance to be selected as part of the sample. Which means that I select the sample without specific order. And I select with replacement. So these are the keywords that you must put in when you explain random sample. So if without replacement, it's not random. And that's why they say you have to keep the sample size as small as possible, so that the chances of the first one selected from the population is almost equal to the second one that is selected from the population. Do you get me? That is the second bullet. I tell you, when